Good afternoon, Michael Mazarang here again, and today I'm really excited to be at a house that we were referred to by a structural engineer that we work with in Charlotte, and he referred us for a specific issue. This house has some foundation drainage issues. The home is built in the 80s, and this neighborhood is rather hilly and typical of a Charlotte neighborhood in this zip code. Wanted to go over a couple things. You can see is where I'm standing. I'm standing at the street level where my car is, and the yard is above grade, and there are many of the neighborhoods in Charlotte share this type of situation where you have all the drainage coming from the street down towards the structure, and that can create erosion issues. This house does have a lot of trees, which is going to help with a lot of that. And I believe they're going to plant some grass here at some point to help correct that erosion issue as well. So working with our solution here to control foundation drainage and protect the sidewalk and the flower beds, what we've done is we've decided to install what's called a drainage swale. I kind of use what I call a French drain plus. Instead of backfilling the soil to the top or the surface of the system, this system is 100% rocks, a control pipe, and some catch basins that have been embedded into the system. We have several going down this the length of this drain. So we started here at the base, the side of the driveway, as well as going along this sidewalk and the flower beds. And what we've done is this is a pipe wrapped in a geotextile sock, and we're going to incorporate many tons of gravel, 57 stone, and then at the surface we're going to put some river rock on top, which is very decorative and makes this drainage swale look very professional and easy to maintain. You can step on it and really never have to worry about it getting clogged because the rocks they act as a filter. So this customer called us from the engineering referral, and they are getting some water into the crawl space. We see that a lot of the plants are older on this home, and plants can do what we call heaving, and you'll see this plant here, which is heaving out of the ground because it's so old and big, and that puts hydrostatic pressure on some of these foundations where water will be forced towards the foundation. Also, what we've decided to do is to tie in all the downspouts on this home to a separate underground piping system, and that will also be tied into a separate pipe that is going along this trench. So we're doing both those applications of addressing above grade water intrusion, surface drainage penetration. We're tying it into this drainage swale. And again, these downspouts are tied into a separate pipe, which is running along the distance of this trench. And you can see here, we use the good stuff. We're using PVC for our control pipe, which is going to make it more effective, easier to clean. Those catch basin locations can also be used as a clean out if the system ever gets clogged. So that makes this system serviceable. Over time, let's say in 5-10 years, it does develop a clog, it can simply be cleaned out. And so you can see here more downspout discharge locations tied into this network here. And we were also invited to look at the crawl space issues, and this is something I really want to talk about, as there's a lot of bad information in the industry, a lot of misleading information that customers will report. But this is a stand-up crawl space. Now, when I first looked at this crawl space, I noted right off the bat that there's not a whole lot of microbial growth growing on the floor joists. We have a little bit here, not much, but the insulation, which is probably 15 years old or so, shows very little tagging, which tells me that there's not a lot of moisture building up in this crawl space. And because it's a stand-up crawl space, it's going to naturally and organically get better air turnover. So many of the companies in this market would immediately try to encapsulate this crawl space, and we don't have enough data to determine if that's really needed. As you can see here, we've had a decent amount of rain. You can see where water is coming in through the front wall. Hopefully our drainage swale will redirect a lot of that discharge, but certainly the water seepage that's coming into the crawl space we want to take care of. So what we've come up here with is basically a slow drip system. We're going to bring in several tons of rock here and disperse that all over this salad bowl shaped crawl space. So basically creating a drainage field. We're also going to remove these wooden shelves, or of course you don't want to put any type of wood in a crawl space in this part of the country, because we have little voracious termites all over this area, all over the southeast, and basically this wood would draw those insects into the crawl space. So we're going to tear this out and remove it as part of the project. All of our drain tiles and the drainage aggregate drainage field is going to be installed. Everything is going to be set towards the left rear corner, and a gravity discharge applied for the system. And all of that drainage will be married together into the system that we're installing outside for the front drainage. So I kind of like this project. Number one, it's easy to see, and I can stand up in here and narrate what we're seeing here. But it's a great project for customers to understand the difference between moisture and foundation drainage and waterproofing issues. And they're all separate boxes that you have to fill when you recommend to a customer what to do here. Since there's not enough data to determine whether we need a moisture control program, we're just going to install an advanced sensor package on the home, relative humidity sensor, and it also will have a wood moisture sensor, so we can keep data on how much wood moisture content accumulates in this crawl space. And by next summer, we can decide whether we need to come back and add additional pieces of equipment for this customer, and we'll have the data to back it up. Before making that kind of a recommendation and spending that kind of money, especially on a stand-up crawl space that's already pretty healthy, we want to give our customers the chance to accumulate data and put a really advanced sensor program on the house so that they have that opportunity to get that data and to track it for us. So, really good project here. This crawl space will clean up very nicely. We'll put a good vapor barrier down, of course, the drainage program. And in concert with everything else we're doing, I'll make a return visit to see the finished product, of course. But you kind of see the nuts and bolts of what we're doing in here. Some regrading we'll have to do to make all this work, but we're going to force all the water that's coming into this corner, gravity discharge, and that gravity discharge will be tied into our drainage swale to underneath it under a separate hard pipe, and everything is going to discharge right back here. We've got a nice little natural area where a lot of water flows through there when it rains. So glad you were able to join us here for part one, and then I'll do part two here in a few days when we're finished. Thanks for joining us. Talk to you soon. Here we are at part two of the video, and the guys finished up yesterday with the final installation of the rocks. And as you can see, we've completed the foundation drainage improvements here, and the customer picked a very pretty river rock, in my opinion. Good color, kind of matches the color of the brick. And we've also put down some seed and a little bit of straw here to try to get some grass growth along the drainage swale path. But this worked out really well. Keeping the downspouts clean and free flowing, combined with our new underground piping system that is incorporated into the swale. We are now able to catch all the drainage coming from above grade, as well as the gutter discharge. And we're able to work all this towards the back of the home. You can see here our small 4-inch catch basins that we've also incorporated periodically through the drainage swale. And it just turned out really nice. And we've had a lot of rain here, so we're gonna have to let things kind of dry out here and just let some of the grass seed take root. But considering the amount of rain we've been receiving, the job site cleaned up rather well. And you can see here at the terminus of our drainage swale, at this point we now go to an underground piping system, and our underground pipes go this way down to the edge of the tree line here, this natural area. And you can actually see here our exit pipe here. We've already seen a fair amount of water pass through the system. You can see where that's discharging neatly and cleanly into the natural area. So also the crawl space cleaned up really well. We tied in this downspout discharge as well as a gravity drain for the crawl space into a separate underground pipe, and that's tied into the system. Turn on some lights here. As previously noted, we just put a standard contractor grade vapor barrier down over this crawl space soil. Got rid of the lifters, and because it's a stand-up crawl space, we decided to turn this bowl-shaped crawl space into a drainage field. We've put several tons of this rock down as a base layer, and then installed a standard contractor vapor barrier over the top. Certainly no need to encapsulate here, as many vendors would attempt to do. We just didn't have enough evidence that that was necessary, so all the vents on the home have been opened to engage the outside air. And just to show that we don't need an encapsulation on this home, take a wood moisture reading here today, and we're showing wood moisture levels of 11%. So you know, there's not enough data to show that we need to seal this crawl space. And so what we've done is we've deployed an Atmox sensor package, not the system itself, but the Atmox sensors, which entails an intake, or I'm sorry, a crawl space wood moisture sensor, which is attached to a floor joist above. We'll show you a picture of that here on the screen, as well as the standard sensor package that calculates or reads the temperature, relative humidity, dew point, that kind of thing. And we'll collect some data, and as we approach the summertime, we'll decide whether or not we need to add additional moisture control measures to this crawl space. But based on the evidence and the condition of the floor system when we got here, this crawl space turns over air really well. And so it's important to remember the industry does push the encapsulation protocol pretty hard, and not every crawl space needs an encapsulation. So note that please get other opinions, as well as professionals that will look at the crawl space from multiple points of view. And always remember, no crawl space is the same as the next crawl space. Up and down this entire street, each crawl space may have a completely different dynamic and must be evaluated from a completely different way. So we ended up here really nicely, cleaned up really well. We've got the drainage field, we've got the gravity discharge, we've got the sensors in place to get more data. We've got the foundation drainage in a much more reasonable manner corrected, diverting all that water to the back. And so hopefully this customer will have years of good service out of this system. And if you want to get more information on foundation drainage improvements, waterproofing, encapsulation, control ventilation, sensors, dehumidifiers, and so forth, give us a call at the number under your screen, and we'll be glad to provide an impartial analysis of that by phone or an on-site inspection. So again, this is Michael Mazarang. Again, thanks for joining us today on this installation, and we look forward to hearing from you in the future and helping you with your crawl space challenges. Hope you have a good rest of the day. Thank you very much. Take care.